Okay, hello. So this is our last lecture on the sequence part of our final topic. And we spent last lecture kind of talking about the difference between arithmetic and geometric. So now we're going to talk a little bit more into detail with those two. So we know what sequences are. It's just a list of terms, okay? Where the range is actually the term's value, the value itself. Like let's see here, -7, 4, 15. These are all range values. This is the first one, the second one, the third one. So when I say first, second, third, that's the domain. The domain is 1, 2, 3, 4, etc. Okay, but since it's arithmetic, what does that mean? What do we know? There's something called a common difference. We can add the same real number every time to get the next value. And that number can be positive or negative. So in general, you have the first term, so let's just call it A. What's the second term? If it's arithmetic, it's just A plus D. You just keep on adding the common difference every time. Well, what's the third term? You would add D to this. So it's A plus 2D. And then the fourth term, well, you added D to this. So that's A plus 3D. And you notice the D's that you're adding, they're always kind of one behind the term you're on. So here, this is the third term, but you're only adding two D's. This is the fourth term, and you're adding three D's. So following that, what about the nth term? So the nth term is like the generic term. It could be the 11th term or the 81st term or the 700th term. It's just, what is it in general? Well, notice it's always the A value plus a certain amount of D's, and it's one less than the term you're on. So you would add two D's in the third term, three D's in the fourth term. So you would add n minus one D's for the nth term, and this happens to be the explicit formula for any arithmetic sequence. You have the first. This should be the first A value plus n minus 1 times the common difference. And then recursively, we always add a D to get the next term. So the nth term is always the previous term plus the common difference. And when you have recursively, you're always given the first term, so you're given A1. So that means this recursive definition is true for n equals 2, n equals 3, n equals 4. So the third term, the fourth term, the fifth term, that's why you have this n is greater than or equal to 2. So let's do a couple of examples. I'll do one example, and then you pause the video and try to do this one. So I've got a sequence, and I first recognize that it is arithmetic. To get from -7 to 4, I would have to add 11. To get from 4 to 15, I add 11. To get from 15 to 26, I add 11. And I have to find these four things. The first one is the common difference. Well, that's the 11. If you keep on adding the same thing, that's the common difference. Find the 73rd term. I have the first, the second, the third, and the fourth term. You could just keep on adding 11 until you get the 73rd term, but I don't want you to do that. That's the last resort. Let's use what we know. We know that on all arithmetic sequences, the nth term, any old general term, is always the first term plus n minus 1 times d. Well, I know the first term. In this case, it's -7. And I know D is the common difference, which is 11. So I think I should have enough to find the 73rd term. So here, the 73rd term. So instead of n, I write 73 equals the first term plus n minus 1. So instead of n, 73 times the common difference. And now this is pre-algebra. So that doesn't mean it's easy. It just means that it needs to be mastered. We need to be masters here. So don't skip steps. Don't rush it. Get this right. We have to follow order of operations. So grouping symbols first, 73 minus 1, that's 72. Then I've got addition and multiplication. So you got to multiply. And then now we can add. And so what does this mean? This means that the 73rd term is 785. The recursive form, well, it's always the nth term is just the previous term plus 11. And that's true for all n values greater than or equal to 2. But then you also have to include the first term. You have to kick it off. And the first term is negative 7. Explicit form, well, the explicit form is the nth term without the recursive form. So it's just negative 7 plus n minus 1 times 11. And you can simplify this up. That's probably preferable to simplify this, distribute the 11, combine like terms, etc. Let's just do that really quick. If I distribute that 11, I get 11n minus 11, and negative 7 minus 11 is negative 18. So that would be the best way to, you always want to what's it called? Express things in their simplest form. So there it is. All right, pause the video and you find these four with this sequence. Please pause the video and work it out. I very much hope you did. Here are all those solutions. So again, pause the video and check your work. Last slide, geometric sequences. We learned last lecture that geometric sequences are just to get the next term, you multiply by the same thing, the same number. And we call that number a common ratio. And that ratio is a real number. So it could be negative, it could be positive. It's not going to be 0. So that would be silly. To multiply by 0, it would just be a list of zeros, and that's not any fun. So we should really say it's the common ratio is any real number besides 0. And just like before, let's investigate. The first term is always a. Now, how do I get the second term? In a geometric sequence, you would multiply by r. How do I get the third term? You would multiply the previous one by r. So that's a times r, which is r squared. And a similar pattern is emerging. In all these terms, you always have the first term, a, and it's always being multiplied by a certain amount of r's. In the fourth term, you're multiplying by r to the third. In the third term, you're multiplying by r to the second. So in the nth term, you're multiplying a by r to the n minus 1. And that is the explicit formula for a geometric sequence. And the recursive formula, the nth term is just the previous term times r. And that's true for all n greater than or equal to 2. Same thing, you're going to try this. We're going to do this one together. Here is a sequence, and we're going to find all four of these. First, well, we know it's geometric, but what if we didn't? How do I know? You have to think, well, how do I see a pattern? How do I get the next term? And we can see the pattern. It's alternating between negative 2 and 2. So the next one's negative 2, and then the one after that is positive 2, etc. Now, are you adding something to get the next term? I mean, to get from negative 2 to 2, you could add 4, but if you add 4 again, you should get 6, but you don't. You get negative 2. So it's not arithmetic. It is geometric, but what is the common ratio? What is the common ratio? It is negative 1. Negative 2 times negative 1 is 2. 2 times negative 1 is negative 2. Negative 2 times negative 1 is positive 2. So that's the common ratio. The 10th term, well, remember this investigation. Any old term is that first value times the common ratio raised to the n minus 1. Well, I know the first term, and I know the common ratio. And I know I want to find the 10th term. So n is 10 here. So I have all these details. A10 is the 10th term. Negative 2 times the common ratio raised to the 10 minus 1, which is negative 1 to the 9th. Now, may God have mercy on your soul. If you multiplied negative 2 and negative 1 and got positive 2, you are breaking the order of operations. We have to do, it's not up to you, it's not up to me. We are all following the order of operations. Negative 1 to the 9th. We've got to do that first. Well, that's still negative 1. You have an odd amount of negative ones, so the negatives don't cancel out. And then now you could do -2 times -1, and that's +2. And you see how I'm showing my work, just like you show your work on the test and quiz. The recursive form, well, it is any old term is just the previous term times -1. Come on now. And then you also have to identify the first term to kind of kickstart it. The first term is -2. Okay, that's the first term. To get the second term, you take this times -1. And down and down and down you go. The explicit form, well, we use the explicit form in problem in number 2 here. It's the first term, a1, times the common ratio raised to the n-1. You try too. Can you find these 4 solutions to this geometric sequence? This is the last one. Please pause the video and find those. Well, I hope you did. And these are all those answers. The common ratio was 1/10. To get from one term to the next, I hope you can see that you're really just dividing by 10, but that's the same thing as multiplying by 1/10. So to find the 12th term, you take the first term times the common ratio raised to 12 minus 1, which is 11. 1/10 to the 11th is 1 to the 11th, which is just 1, divided by 10 to the 11th, which is 10 to the 11th. And now we're multiplying. 8,000 times this is really 8,000 divided by 10 to the 11th. So it's 8,000 divided by 10, 11 times. You end up getting this. There's the recursive formula and the explicit formula. And that is it, my friends. You now are totally equipped to enjoy the sequence homework on my math lab, and that's due this Friday.